Good evening. Today, this is Dr. Asadi. Today, I would like to explain my conference paper title is Advanced Prediction and Detection of PFAS in Groundwater, a comparative study using ECNN and ERNN techniques. ECNN stands for Extended Convolutional Neural Networks and Extended Recurrent Neural Networks techniques. We are finding the contaminants in the groundwater, the concentration levels on groundwater data set. And myself, Dr. Asadi, and my colleagues are Professor Anupam Agarwal from Indian Institute of Information Technology, and my colleagues are Dr. Alvin Lal and my supervisor, Professor Ravi Naidu from University of Newcastle. So welcome for this presentation. These are the contents I would like to explain for this conference paper. Abstract, introduction, objectives and goals, methodology, proposed architecture, performance metrics, results, discussion, conclusion, references. Coming to abstract, so we are choosing the groundwater data set from different countries, and this research highlights comparative study using extended convolutional neural networks and recurrent neural networks to improve prediction and detection of PFAS concentration levels in groundwater. PFAS is nothing but per and polyfluoroalkyl substances. Those are the contaminants, demonstrating the superior performance of ERNN in terms of accuracy and robustness. So, coming to introduction, this research outlines a study or research comparing ECNN and ERNN techniques from deep learning techniques to improve the prediction and detection of PFAS concentration levels in groundwater. Especially we are addressing challenges in data limitations. With help of these models, generalization and interpretability are the issues we are overcoming in this paper. Then the objectives and goals of my research is it is to enhance the detection and prediction of PFAS contaminant concentration levels in groundwater using deep learning techniques and models. A model is nothing but a simplified version of the reality. It is aiming to improve predictive accuracy, robustness, and practical applicability for environmental management. These are the performance metrics for validating whether our results are showing correct or not. Then this is the methodology. We are following various steps in order to implement ECNN, ERNN methods, applying on advanced data pre-processing method. There we are eliminating noisy data, redundant data, inconsistent data from the groundwater data set we have collected from various countries. Then we are performing augmentation and then hybrid feature extraction techniques to predict and detect PFAS in groundwater with the performance evaluated through mean square error and R square metrics. Then the architecture of my research work is structure, which comprises software and hardware components and connections among them. These both the models are combining and we are enhancing, and we are predicting detecting PFAS concentrations in groundwater, leveraging advanced layers and mechanisms for improved accuracy and robustness. So this is the proposed architecture. We are following the steps. We are performing 70% of groundwater data in training data, and 30% of groundwater data I am using for testing, and validation data I am using various performance metrics. We are choosing deep learning techniques. Then out of ECNN, RNN, we are selecting the best methods and frameworks we are integrating. Finally, we are getting the classification of concentration levels of PFAS. Then this is the groundwater and PFAS concentration synthetic data set. So here various columns like sample ID, latitude, longitude, path, and temperature, pH value, conductivity, dissolved oxygen, nitrate, PFOS, PFOA, PFHX. These are the concentration levels. Total PFAS, airport distance, industrial area distance, agricultural area distance, and urban area distance. And this is the groundwater data set we are selecting. Then we have applied successfully ECNN and ERNN technique. The performance of ECNN and ERNN models was evaluated using mean square error and R squared metrics, and we got ECNN and ERNN mean square error and R square error values. So mean square error value is 3182.49 and a higher R square value is minus 0.069 compared to the ECNN model, which had an MSE of 4155.57 and R square value of ECNN is minus 0.396. And these are the results we have successfully executed. It indicates that ERNN model achieved a lower mean square error, that is called MSE, of 3182.49 and a higher R square value of minus 0.069, demonstrating better predictive performance compared to the ECNN model, which had an MSE of a mean squared error of 4155.57 and an R square value of minus 0.396. So these are the graphs, a comparison between ECNN model predictions, ERNN model predictions, the comparison. In x-axis we are taking measured and y-axis we are taking predicted. So ERNN model shows the better accuracy and performance comparatively ECNN model. So in this groundwater we are highlighting the advantages of utilizing recurrent neural networks with attention mechanisms for capturing temporal dependencies and improving prediction accuracy. And this is the comparison of existing versus proposed system with parameters like model type, primary focus, data utilization, feature extraction, maximum mean square error, maximum R square value, prediction accuracy, robustness, interpretability, overfitting risk. So comparatively existing system ECNN, and we got very good accuracy and performance by using proposed system ERNN with these parameters. And the future direction of my research work, if you integrate of additional deep learning frameworks and hybrid models, inclusion of VGG16, ResNet, GoogleNet, few more frameworks to further enhance the predictive accuracy and robustness in detecting PFAS concentrations in groundwater, as well as expand the scope to include other environmental pollutants and diverse geographical regions. This is the conclusion of my research. Research analysis confirms that the extended recurrent neural network model outperforms the ECNN model in predicting PFAS concentrations in groundwater, as evidenced by its lower mean square error, that is MSE, and higher R squared values, highlighting its superior predictive accuracy and robustness. These are the top 15 closely related literature survey papers I have downloaded, and I have done comparison and literature survey, and I have taken common drawbacks of each paper, all the 15 papers, then I have implemented successfully. Thank you for giving me this opportunity.